Hello and welcome to the AIM webinar series. My name is Mary Lou Bosco, and I'm the Chief Executive Officer for AIM Global. Today's webinar is Unleashing RFID to Create Innovation. And our speakers are industry experts, Dwayne Roebuck, Anu Koshla, Peter Collins, and Claude Tetlin. AIM is the premier source of industry support for the automatic identification marketplace. For more than 50 years, companies have joined AIM to lead growth of our industry. AIM serves as the hub for quality resources covering all types of barcode, RFID, and other asset tracking technologies. We also serve as an incubator for new auto ID innovations that grow the market. AIM delivers trusted resources that connect you to new customers and business partners. We encourage you to get involved. If you'd like additional information, please email info@aimglobal.org. This next slide reviews AIM's antitrust policy. The AIM antitrust states that we conduct our operations in strict compliance with the antitrust laws. No AIM activity shall create even the appearance of a violation of the letter or spirit of the antitrust laws. All attendees are included to actively participate in all meeting discussions. All meetings shall be conducted in a manner that avoids the appearance of any conduct that might violate this policy. Before we begin, I'd like to review a few housekeeping notes for our participants. All participants are muted when they entered the webinar. The webinar is being recorded today and will be available in the upcoming days. To send a question, select the Q&A icon at the bottom of the webinar application. Questions will be answered at the end of the presentation. Without further ado, I'd like to thank again Bluestar, Anatix, A2B Tracking Solutions, and GS1 Global Office for their support of today's event. Introducing today's panel is Dwayne Roebuck. Please join me in welcoming Dwayne in today's panel.
Thank you, Mary Lou, and a pleasure to be here. I'm Dwayne Roebuck, the Channel Strategy Manager at Bluestar for retail, hospitality, IoT, and RFID. And if our panelists don't mind, I'd like each of them to give a brief introduction, and then we'll jump right into some of the topics. So could you lead us off, Anu, and then Peter, and then Claude?
Sure. Thanks, Dwayne. Thanks, Mary Lou. My name is Anurag Kulshrestha, and I'm the owner of Anatix. We are RFID and IoT solutions provider. We work with the federal government clients. We work with the commercial clients in different countries. Thank you.
My name is Peter Collins. I'm the founder and CEO of A2B Tracking, where we do common sense RFID deployments into manufacturing and distribution environments, as well as also into state and federal government.
Okay. Hello, everyone. My name is Claude, and I'm working for GS1 Global Office for more than 5 years now in the AIDC team, which means automatic identification and data capture. I am in charge of RFID related topics, like, for example, the revision and update of GS1 standard, like the Gen2 Air Interface Protocol, tagged item performance protocol, and also device certification. And I am supporting the GS1 community by providing some kind of education materials that include trainings, webinars, and best practices.
Cool. So without further ado, we'll jump in and start tackling some of the topics that we believe our audience would really like to hear. And as Mary Lou suggested, please feel free to send out any questions you may have, and I'm going to do my best to get our panelists to address those questions and hopefully get you some answers. So we've all been hearing for years, I can speak for myself at least, since 10 years ago when I started at Bluestar. This was the year of RFID, that was the year of RFID. Now we're actually seeing, where RFID is being widely deployed in a variety of scenarios. Myself, I see it on the retail side in terms of inventory tracking, as well as loss mitigation, and operational efficiencies for the employees. Where are some of the areas that you are seeing it deployed, and what are some of the use cases that you're seeing driving it? Like what's some of the innovation, behind it? So any of you guys can, jump right in. Well, I'll tell you what, in this format, can you start us off, Peter? And then everybody else can just, jump on in as you see fit.
Yeah, Dwayne, thanks for that lead in. I'll tell you from our perspective at A to B that where we, really the areas of many areas of discrete manufacturing have started in some form to adopt RFID. There's a lot that goes on in a manufacturing process. There is everything from receiving of raw materials to put away of those raw materials. There's the buildup of raw materials into sub-assemblies and final assemblies. There is tracking of finished goods, making sure that when sales orders are getting processed, that final shipments are being identified and tracked, going on to the right truck in transit to the right destination. So you can imagine, since the dawn of manufacturing, tracking of inventory has always been a challenge. And, I am really amazed across every area of those business processes I just cited. We're seeing some form of RFID implementation and being done very successfully. I'll add too that distribution is another area. Now, we don't do as much work in the retail, but we work definitely in the more industrial distribution areas of the industry, supporting government and military applications, and the distribution centers too of picks and putaways and all the same kind of verification and validation. Very powerful for RFID. That's for us.
What about you, Anu? I know you guys at Anatics, you do, quite a bit, piggybacking off of what Peter said. You guys do a substantial amount in government as well. What are you guys seeing, and what's really driving the adoption?
Yep. So I'll give you some use cases now. So earlier we used to track within a confined environment. It could be a warehouse, it could be a manufacturing plant, it could be an office. For example, we are working with Amtrak right now, and they're in the 46 US states. So things are spread throughout the United States, and things are not stationary. They are moving all the time, like trains are moving. So what we are doing, instead of putting the RFID tag on the surface, we are embedding the RFID tag in the concrete mix itself. So when concrete ties are manufactured, right, so we know which was the purchase order, who supplied the steel, who supplied the concrete mix, where it was manufactured, and so on. And then this concrete tie, concrete piece is moving from the track laying machine to different track in different states and so on. So we have installed the RFID antennas under the belly, underneath the train platform. And while it is scanning the RFID tag, it's also telling the GPS location of it. So not only that where I am and who I am kind of thing. So both the things are coming together. And in some cases, we are using the sensor tags, sensor RFID tags, passive UHF RFID tags. So it could be the wine barrel, or it could be the storage area of the weapons where we are, we have to maintain the humidity and the temperature. So nowadays, RFID also, passive UHF RFID tags also giving you the sensors information. So there are many use cases are there, and then we integrate the RFID with other technologies such as IR, infrared technologies. So we are doing that people's counter, let's say people counter, we have it using infrared as well as we have the passive UHF RFID tags. So many possibilities, and as we open up, we'll discuss more. Thanks, Dwayne.
Cool. Last but definitely not least, I'm told that we have a substantial amount of international attendees who have registered, for this webinar. So Claude, could you give us, like Anu and Peter have both talked in terms of things that are going on here in the United States. Can you give us more of an international perspective in terms of, use cases that GS1 is seeing, and some things you guys, might be seeing that could, be a little bit different than some of the things we're doing here.
Oh, yes, thank you, Dwayne. Yes, GS1 is mainly addressing the retail and healthcare sector, but we also propose a lot of different standards to tackle some business needs in other sectors like construction, maritime, and also, for example, fresh food. And we see more and more people using UHF passive RFID, not only to benefit from the fact that RFID is tailored and designed for high-speed and accurate inventory, but also to leverage the fact that when you are using RFID, you are identifying the product, asset, item, whatever you call it, at instance level. It means that you have to serialize your identifier in order to leverage from RFID. And we see more and more also people adding a layer on top of RFID itself, what we could call artificial intelligence, or however we call it. But in order to gather all this information that are captured by the RFID readers and to analyze that in a way to provide much more information than just an identifier or just making an inventory. But if you allow me, I would like just to give it some kind of an advice to those who are adding artificial intelligence to an RFID application. An AI is like any other engine. And if you don't feed the engine with proper fuel, you will probably not have the expected outcome. So my advice would be to say, be careful about the way you are encoding the RFID tags, because to provide reliable predictive insights, and AI systems need to gather and analyze a huge amount of data. And if this data is not accurate, you will probably face some kind of an issue. So you can make use of GS1 numbering system, obviously, but this is not the only way. You can also make use of other way to uniquely identify items or products. But please do that in a fully standardized way so that you will have no issue when you will gather all this information, and you will make sure that every information that is used and analyzed by your artificial intelligence system or your engine, I don't know how to call it, will provide you with the right level of information and will be as accurate as possible.
Cool. I mean, piggybacking off of what Claude just talked about, Peter and Anu, are you guys seeing, everybody's talking about AI and, as Claude said, predictive analytics, trying to get more information and trying to get a competitive advantage. How are you guys, just a couple, maybe one or two brief, use cases in terms of how you guys might be seeing AI or predictive analytics entering into your markets, and how are your customers leveraging it, and what are some of the benefits that they want to derive out of it? So, I'll leave it up to you guys in terms of who jumps in first. But, if you guys can help us with that.
After you, Anu.
Okay, thanks, Peter. Thanks, Dwayne. So yes, I know that Peter had a lot to say about the AI, so I'm gonna just touch another tangent before the AI comes in picture. So all the RFID readers, antennas, network appliances, how do we make sure they are in the secured environment? How can we trust data at rest, data in motion, right? The cloud security, cyber security, because any federal agency, nowadays is zero trust. How do we trust even the bits and bytes coming from a particular reader or any network appliance, right? So first we have to make sure we can encrypt the data, and not only we encrypt the data, we make sure that we can trust the device which is going to send the data to a particular IP address at a particular port, right? And so, and then thereafter the use case and the modeling for the AI. So I'm gonna just, like divert that question to Peter, but I just wanted to have the thoughts in that it's not just simply you are connecting the RFID reader to your network system and suddenly the data is coming. How are you gonna make sure nobody is counterfeiting the data? Nobody is, messing up with the data. And more than that, how can you trust that network appliance or that RFID reader? To you, Peter.
Yeah, thanks, Sanu. I think it's a great question, Dwayne, that you share. As far as how do these technologies blend together. I tend to always look at the business problem and the process first before thinking about how the technology applies. And I'll give you, for instance, in a distribution facility that we're working with at A2B, where the process is that the way that they put away pallets of product across numerous 500,000 square foot warehouses is that they do it in a way that actually makes sense. They rack and stack the different pallets according to a methodology that's dictated by their customers that they serve. The problem with that is that they end up putting inventory many layers deep, 4 or 5 pallets deep, as for instance, in this case. And what happens is there's seasonality to that business. The distributors have to make sure that at certain heights of their shipping requirement, that they're actually serving up a pallet to go out the door every 5 minutes in that operation. And so what's happened here is that they can't meet that obligation. Sometimes it takes 10 or even 15 minutes to find a pallet. And you can imagine the disruption, the downstream repercussion that has on getting product out to the customer on time. Now, in comes RFID. What happens with RFID is not only is the item actually now in a much more accurate way being properly put away, it's coupled with locationing technology. And so when you couple the IDs, the identifiers, with locationing, with a scheme that is consistent in the warehouse, now you have a very methodical way of putting away. So when someone goes to pick those items, then they're going to know where those items are. Once you've done that, now you've put the infrastructure to layer AI on top of it. And AI with larger facilities in particular, where there's multiple routes to get to that inventory, AI can do the pattern recognizing to say, this is the most optimal way of getting to that inventory in order to make sure that you meet the 5-minute deadline of getting that pallet shipped. So RFID coupled with locationing coupled with AI really becomes a powerful combination. And this is all very doable, very real technology today that can help the warehouse in that case.
Well, I'm going to piggyback, and this was going a whole different direction than what I originally anticipated, but both Claude and Anu brought up, concerns or challenges in terms of not only, leveraging AI, but making sure that it's quality information. Claude pretty much said it. If you've got bad data coming in, it's going to give you, bad actions coming out. So from your perspective, without, giving away any secret sauce or anything like that, Peter, how do you see your customers securing the data and ensuring, that the data that comes in is quality?
Well, we're in environments too that have a lot of stringent security requirements around the data, because we're dealing in environments where there is sensitive data. That data needs to be localized and stored in a secure way, or even offered to the cloud in a secure way, which is very capable of being done today. The concept of authenticating to the device on a network is really important here too. That issue hasn't been a tremendously large issue for us at A2B. because of the way in which these devices are assigned to the network and locally used in a meaningful way, because it's an internal closed loop system in most of the cases that we're working in today. So long as it's inside the firewall, being protected properly, then it comes down to the real question of, when there's so much RFID data being captured at various points in the process, how do we interpret that data and allow that data to provide the business intelligence of what's happening in the physical world? So it's one thing to say, geez, we've got a reader that's reading at 500 tag reads per second at this particular location. But how do we know that that means, okay, an item is moving from one process to another or one location to another, with the use of additional sensor data that can tell us, okay, I know the direction that it's moving. So I get better visibility into my operation, making sure we know, okay, I've got that full view and I can trust the data. And I think that's what it comes down to, is the very notion of trusting what we're seeing on the dashboards in front of us, reflective of what's happening in the real world.
Thank you.
Dwayne.
So yes.
Yes, Dwayne, if
I was
may-
actually just coming to you, Claude, for a different question, but jump on in, man.
No, just to complete to what has been said, and I would like to emphasize that sensor data, location, together with unique identifiers are really the keys for creating on top of that an efficient AI system. But we see also more and more people trying to encode more than just an identifier or unique identifier in RFID tag. And this is another issue that people may face. How do we encode additional information like, I don't know, an expiry date, a country of origin, any other attributes that we want to assign to an item in the RFID tag, to make sure that we will not face any network issue when we will access to this information. We just have to read the tag. And this is very important to have that in mind, that today we can append such kind of information to the unique identifier in a way that when you do the inventory, you do not capture only the unique identifier, but also the attributes. Of course, the drawback of that is that it will take a little bit more space in the RFID tag, so you need to make sure that the tag can support all this additional information. But this is something I think should be in mind of all the people who will implement RFID in the future.
Man, I'm loving this. You guys are taking me completely in a different direction than, some of the questions that we had. Since we're talking about sensor data and storing it on RFID, if you don't mind, Anu, you were talking about motion sensing, getting GPS, that sort of thing. How are you guys leveraging the technology and leveraging what Claude just stated to ensure, accurate, data and information, which I'm assuming is going into some sort of generative AI thing, so that from a train perspective, you can see when they're coming, how fast they're going, those sorts of things. So can you, I guess, enlighten us in terms of that?
So good thing is, doing and team today, the RFID readers which we are using is already have the full active GPS module. So whenever it's reading, it's giving me the latitude, longitude, date and time, speed, elevation, so lots of other data is coming with each possible read. So it's not about the EPC, it's about the reader, which is connected with the GPS external antenna. So I'm getting 5 or 6 geo coordinates along with it. And one other point before I miss it, what Peter said, in some time, yes, we had the closed environment and we keep all the network appliances and RFID data inside it. In my case, like Amtrak use case, for example, the trains, Amtrak, providing any network connectivity to us, we are responsible for it. So we are using Cradle Point 5G routers on the trains, but Cradlepoint is an external entity. And how do I trust the data coming, which is being forwarded from my reader to Cradlepoint to the Amtrak system? How they trust this one, right? So one thing is definitely we are doing the IP whitelisting. So we know what are the IP addresses, what are the MAC IDs of our devices, but still we cannot directly send the data from those devices. So what we have the edge appliance on each train, and that's where first the data comes in, and we encrypt the data. I mean, we have the first security vanguard kind of point right at the edge appliance, and then we have the public private key, and we are sending data to the AWS or Azure, whatever the secured cloud client may have it, right? So G and the sensors data, like other point you said it. So what we do in the sensors data, in the user's memory, like you know that RFID tag has different kind of memory, right? So in the user good and bad things are there are no standards yet for the sensors RFID tags. So different IC manufacturers and the tag manufacturers have come up with their own standards, right? So for example, we talk about the Tagios, or we talk about Assign. These are the two large companies who are manufacturing even uh, uh, I mean, many companies are out there, but there are no standards. So some companies are using the different bits and bytes to send the some raw data about the sensors, but you cannot still take this raw data and convert into something. So you have to have some coefficient factors loaded in your database, because each IC, when it goes through its process, it creates different, you can say, the raw data, and you have to use this raw data and the sensors data coming in and do some kind of calculation on the fly, and that will tell you the humidity, temperature, magnetic field, ambient light, and so on. So in other words, what happens if we have the fast moving, uh, I mean, we have to fastly read the data and process the data. It will slow down the process, because at the real time process, whenever read is coming, whatever millisecond it is going to take, it's taking it, right? The microsecond, the processing. So depending upon the use case, we can either do the post processing, or sometime if the real time processing is needed, then we may have to need the high power computing machines, HPC machines, right? Because otherwise the system can't do it. I'll give you a case in point. One of our client data we are getting the 25 billion data reads in a week. It's too much data. So if we have the normal computer, normal server, it can't keep it up. Do it.
Wow, that is a lot of data. Are you seeing similar things in the warehouse and manufacturing area, Peter?
Yeah, without question, we are all here in the RFID world data rich. We're not short of data. It's just how we handle it in a meaningful way that becomes so important in the environments we're going into. And I think to a news, point, like his extra focus on not only the locationing piece of it and how important that is for that real-time visibility of where items are moving, but then also how do you recognize the fact that you're going to get so much data feed? How do you securely process that in a way that provides the business visibility and the business analytics for somebody to make some smart decisions based on that data? I think is so important. I'm also going to comment, Dwayne, for just a moment on Claude, because he brought up we were talking about the topic of trust in data and how RFID can help enable that. And Claude may have some additional comment on this, but I know one of the key areas of industry that has been leveraging RFID is for those that are working on brand authentication. And because RFID tag can be secured in a meaningful way, where someone, who might try and game the system, can't find the keys necessarily to unlock that RFID code and insert something, that would be malicious as a brand into the supply chain. RFID is doing, a good job of really helping establish that extra brand protection as well. And I know GS1 is a big part of that. So, Claude may want to comment on that.
Well, I tell you what, they get to you, Claude, every time I'm about to. So take it away, man.
Okay, Dwayne. Yeah, yes, Peter. Yeah, when we talk about RFID and generative AI, we think about capturing a lot of information, and as it has been already emphasized, we need to make sure that we capture the proper data and analyze it in a proper way. But even if we manage to lower the amount of data just to focus on what is really important for the application, you have to keep in mind that a lot of other users will have the same kind of I would say application. So it means that when you will have a reader or multiple readers trying to capture RFID tags, you will not only capture the tag that belongs to your application. And this is an issue because you will have, in order to make your application more efficient, you will have to focus on the tag of interest. And this is very difficult with the previous RFID air interface. And this is one of the reasons why within GS1 we decided to review this air interface, is really to help people to focus on tags of interest. We did that in a way that, for example, you can easily filter the tag only based on simple selection criteria, like I want only to focus on the tags that are encoded with a GS1 identifier. It's simple, it's straightforward. But you can also, with this new air interface, have much more complex filtering criteria, like, I don't know, I want to inventory GS1 tags, but only tags that carry an expiry date and for which the expiry date is greater than a targeted value. And I want also, for example, to inventory the tags for which a monitored temperature has been greater than minus, I don't know, 18 Celsius degrees. Just to focus really on tags of interest, and you can do that in a very efficient way, so that you will once again feed your AI engine with only very relevant information and nothing more. And you will not waste time in capturing unwanted tags that you will have to capture, decode, analyze, and after that to say, oh, this tag does not belong to my application, so I will not make use of that. And as I said at the beginning of this webinar, tags can sometimes carry additional information that is really difficult to capture. It could be a sensor measurement, it could be an expiry date, it could be whatever you want. And with the new GS1 air interface, which is called Gen2 V3, version 3, you can really efficiently capture this information. So this will also increase the efficiency of your application. And last but probably not least, I think everyone who experience the use of RFID, when you do tag inventory, you will probably see that you will capture 95% of the tags that are in front of your reader in less than a few seconds. But it can take a lot of time to inventory the remaining 10 or 5%. And this is mainly due because the tags are not sufficiently energized. So with this new air interface, what you will be able to do is to instruct these tags not to participate to the inventory, so that you will increase the speed of inventory in a way that will also help you to save the few milliseconds that you need to capture and analyze the content of the tag.
Hey, we've got our first question, and thank you, Anu, for jumping in. The question, and I'll pose this to Peter, and Claude, if you guys want to weigh in on it, it's resulting from Anu's comment in terms of leveraging edge computing, and so the question is, are you finding it necessary to use edge computing to manage all the equipment that is part of the system. I'd imagine, Peter, with you working in warehouses and things like that in those areas, you may have some instances like a new where people are leveraging external networks like a new reference cradle point and doing that sort of thing. Are you do you want to weigh in on this question? I'm sure we're going to need more, but just a high level.
Yeah, at the high level, so Claude mentioned something that we can never ever lose sight of with RFID, and that is the imperative for performance. And what I mean by that is not only is the accuracy where it needs to be, the identification, meaning, as the high as we can get into the high 90 percentile of making sure everything gets captured with striving toward 100%, but also can get processed in a meaningful amount of time to provide the results needed. And so edge computing does have a role in that, because oftentimes with so much data being processed, you don't have time to get back to the cloud in order to pull down the necessary information or to make the appropriate determination. Shipping verification is a great example of that. You've got pallet trucks that are loading up onto a delivery truck, and you've got to know if the wrong pallet's going on that wrong truck immediately. And so that has to get processed at the edge in order to give the proper turnaround time on that data and that response.
Did you want to weigh in on that one? Oh, go ahead, Anna.
One thing, Joanne and Peter, I would like to add on, and I'll give you real life scenario with me. So when people thinking edge computing, do not just think external computer, edge computer. Your RFID reader could be edge appliance too. It depends how much it has to deal with it, right? What we have to also think about the rain flooding, we call it. Let's say suddenly you are supposed to read 500 tags, you have a 250,000 tags. Somebody is shipping that 250,000 tags and system can't keep it up, right? So we can do the masking at the RFID reader itself. Then other part is the edge computing. It could be a look device or something. I'll give you case in point why I brought this bit up. So from Texas, 250,000 RFID tags were coming to me in Michigan through the UPS, and somehow UPS goofed up because I know the UPS is using the RFID tags now on the, so suddenly the system goes nuts. What happens, right? And we are trying to track our package. It's sitting somewhere in Illinois. It's not coming to Michigan. So rain flooding, guys, is very important. And so sometimes your system, you are designing for 100 tags or 10,000 tags. Suddenly it sees the 250,000 tags. It goes nuts. And if we don't do the proper edge computing and processing, you will overflood your system. Thank you.
Agreed with that.
You want to weigh in on this? Oh, go ahead, Peter. I'm sorry.
No, I'm just agreeing with everything Anu's saying. I think he's spot on. Yeah.
How about you, Claude? Do you want to weigh in on it, or?
Yeah, just not really about edge computing, but I think everything starts with, and I'm sorry to really emphasize that, but everything starts with the proper tag encoding. It's much more efficient to focus on tags of interest if you know what kind of information you are searching for. So rather than capturing all the tags that just are in front of your reader, if you make use of a proper tag encoding with the right level of identifiers, either using, I will take just one example, an SGTIN for trade items, or an SSCC for shipments, or a GIAI for asset. The choice of the right identifier with the right asset or location that you want to identify is the first step. And after that, the reader will have much more, will be much more easy. It will be much more easier, sorry, for the reader to really focus on tags of interest and only captures this kind of tags.
Cool. So so we're moving into the open Q&A portion of this, And I would encourage any of the attendees that are out there, if you have some questions, please go ahead and put it into the Q&A. So do we have a question, Mary Lou?
Yes, thank you, everyone. Thank you, gentlemen. Do appreciate your time today. There is one question I'd like to pose to this group is what RFID frequencies are best in which applications?
Well, since Anu is, it looks like he's licking his chops at that one. You know, he's smiling. So go ahead, Anu. I'll let you start, and then Peter and Claude, you guys can jump in.
As you know, it's a very wide open question, right? The first thing it starts, in which country you are, what you're trying to achieve. And when we talk about RFID, it's not just everything UHF RFID. We have low frequency RFID, right? HF high frequency RFID, ultra high frequency, VHF. So it depends upon first, what is the objective, from how far we are trying to read. Are we having what is the surface material, or what is the environment? Too much metal, too much water, or no metal, or just, so what is the application, from how far we have to read? So many factors will come in. First, deciding within the RFID frequency band, which one we have to select. And second thing is, in which country you are. Like in the UHF case, different countries have the different allowed the frequency ranges. And sometimes some tag manufacturers have tag manufacturers for United States FCC, or it could be for Europe ETSI, right, at C. So it's a very wide open question, and I would like other like Claude and Peter definitely will have lots to say upon it. Thank you.
Yeah, hey, we need to try to keep them brief, because we do have more questions that are popping in here, so I'd like to get as many answered as possible. So take it away, Peter and Claude.
So if I may just add a few words to what Hanu just said, which is crystal clear. I would say it's not a question of frequency; it's a question of air interface protocol. Depending on the goal of the application, rather you want to have more secure communication between the tag and the reader. If you want to inventory a huge number of tags in a very limited amount of time, you will be forced to make use of either one protocol or another. Could be UHF passive RFID, also named RFID. It could be HF, also known as NFC. It could be LF, but at the end, depending on the need, you will be forced to make use of one of these different frequencies that are available for RFID in general. But it's not a question of using one frequency or another for physical and environmental purposes.
You want to weigh in on that, Peter?
Wait, no further comment on that one.
Okay, so here's the next question. It's from Andrew, and Andrew's asking, how do you see the growth of active devices that power sensors, offline, and enable semi-continuous monitoring until the data is requested? So I'll just let you guys jump in, because I know we've got a limited time. And there's still one more, so please be aware.
Yeah.
I'll say first, I don't have a strong opinion on this one. Maybe Anu or Claude does.
Yeah. So yeah, we utilize different types of active sensors such as BLE, LoRaWAN, ultra wideband, right? So they have their own use cases. RFID, passive UHF RFID, and other RFID have their own use cases. It will all depends upon the use case of the application. But yes, there are many use cases, thousands with the active devices as well.
You got anything, Claude?
No, because GS1 made a giant leap with the release of Gen 2 V3, and we are now supporting the what we call the passive sensor tags. we are not supporting currently any active devices in the air interface protocol. So I'm not aware of any use case that really needs to have continuous monitoring using RFID. You can do that with any other technology, but it's not covered by GS1 standard portfolio currently.
Okay, and this last question, it goes back to the tags being used to capture sensor data. And so what they're saying is it possible to leverage tag memory for applications like temporary sensor data storage?
My only experience there is cold storage applications where temperature data is being captured as part of that. When we at A2B talk about sensors, usually it has more to do with motion sensors where the control of the reader is being triggered by motion, and knowing, what is happening within that at that point in time with the reader capturing the tag data. But a lot of what we do is license plate kind of identification with RFID. So maybe Claude and Anu have something to add there.
Yeah, so we call the sensor RFID tag nowadays. So they're different kind of in the IC itself. The sensing is involved. Temperature data, humidity data, accelerometer kind of data, magnetic field, and the ambient light. So any of the sensor data, and again, it depends upon the IC manufacturer and tag manufacturers, but mostly the people use their user memory, some part of bits and bytes to have the data. So when you are reading some particular byte information from that memory bank, and that's how you interpret what is the value of sensor data.
And I could just add, because we are talking about RFID and sensor, but just to say that the RFID tag can be considered as a sensor by itself. Depending on the environment, the way you are reading and capturing the RFID can vary, and this could provide you some useful information about the environment. Could be humidity, it could be also location. You can make use of the way you are measuring and capturing the RFID to assess the location of an item. And together with the predictive AI engines, you will be able to have a much more better accuracy about the location of a tag.
All right, thank you, gentlemen. This concludes our Q&A session, and thank you to all of our participants who submitted questions. Thank you, gentlemen, for your insights and knowledge today with this webinar on how RFID integration with emerging technologies is driving creativity and revolutionizing the way companies are operating. Thank you also to our audience for their participation today. I hope you found this information valuable. We would appreciate your feedback, so please take the time to complete the brief session evaluation, which will be emailed to you shortly. This information will be used to develop future presentations in our webinar series and also future AIM Global events. Thank you so much for your time today and have a great day.
Thanks, Mary Lou.
Thank you.
Thank you all.
Thank you.